Okay, here's the fourth video. These are on little chunks, mostly because I get interrupted halfway through. But here we're determining the length of EB. EB is from there to there in this pair of similar triangles. So EB and DC are related, as are AE and AD. Now the first thing we've got to decide for ourselves is that 10.5. Is that from here all the way to there, or just from here to here? And if we look at it, 10.5 compared to 7, if 10.5 took us all the way from there to there, and 7 was this part here would be 3.5, so half as long. This is not half as long. This looks a little bit longer than that line as well. So this must be 10.5 just from E to D. And there must be 7 on the other side. So for the big triangle, this whole line's got to be 17.5. Okay, so let's look at these two. We've got 7 and 17.5, which is the length from there all the way to there. Oops. And we're going to set up a proportion. So for the yellow ones and for the blue ones, pairs of lines that are related to each other, if they're similar triangles, they should be proportional. So for the small triangle, we've got EB, which we don't know. We don't know how far from here to here. That's the whole point. And we've got DC, which is 25. That's on the big triangle. On the small triangle, the blue line is 7, and on the big one, it's 17.5. So if we do 7 times 25, we get 175. We divide that by 17.5. We find that this line here, E to B, should be 10 units long. If you would have used not 17.5, but 10.5, then you would have come up with 16.7. And the only reason that's a bad choice is because this from here to here just can't be 3.5. It just looks wrong. So if you chose 16.7, you probably did all the right steps. Just maybe need to go examine whether that looks realistic for the problem or not. Next, when the shadow of a flagpole is 31.2 meters long. Okay, so here is a flagpole. It looks like this. I don't know, it's got a flag on it. I can't draw a flag. Here's the ground. The sun is somewhere, I don't know, up in the sky. It's not that low down, but whatever. Somewhere up there. And we've got a shadow coming down. And the shadow, so there's the part that is over here in sunlight. Sunlight is shining through. Here the sunlight is hitting the thing and not coming back, not coming to the ground. So from there to there, this part is the shadow on the ground, which is 31.2 meters long. And the flagpole, we don't know how tall it is. That's the question. How tall is the flagpole? But it says that at the same time, a fence post. And I'm going to assume here the fence is shorter than the flagpole, just because that's how things normally go. I'll draw the fence post in blue. So the fence post is here. Here's a fence. And it's making a shadow that is 2.6 meters long. And the fence post is 1.6 meters tall. Just to be clear, this 31.2 is from here all the way to here, the full length of the shadow. And the 2.6 is from here just to here, so the full length of the fence shadow. So these are two similar triangles. We know they're similar because they share this angle and they share this angle. They also must therefore share the third angle because they have to add up to 180. So if all three angles are the same, these have got to be similar triangles. So let's take a look. For the height and the height, those have got to be proportional. And for the shadow and the shadow, those have got to be proportional. So for the little one, for the fence post, 1.6 and 2.6. And for the big one, for the flagpole, we don't know, and 31.2. So if we look for our missing one, we take 31.2 times 1.6, we divide by 2.6, and we get 19.5. So this must be 19.2 meters long, which is our choice here. It's D. Here we have to make one assumption. So it says when the shadow of a flagpole is this long, these two shadows are cast. That just means that the sun is at the same elevation, that it's not like measuring one at noon and measuring the other one at sunset, where the shadows might be really big or really small. Those questions with shadows are always going to be same time of day. Determine the value of x. Here's a nice simple one. We know that all of the angles in a triangle, they add up to, this symbol I'm drawing here means sum. You'll probably see it. You've maybe seen it before, maybe see it later. Sum to 180 degrees. So this angle here is 90. This angle here is 65. Plus our unknown, that's a degrees, not a squared, should sum to 180. So if we're looking for x, we're going to take 180 minus 90 minus 65, and 180 minus 90 is 90. 90 minus 65 is 25. Looking at our choices here, we can at least knock out A without even looking, because 115 is way too big. If we took just 115 plus 90, that'd already be 205 degrees, which is more than is in the whole triangle. Plus there's a 65 waiting up here. Way, way, way too big. So we know A is the craziest answer here. B and C are pretty reasonable. D's too big. D would be the case if we had an isosceles triangle, but we clearly don't. Next, determine the unknown length. So this is the long side. This is the hypotenuse. It's opposite of the right angle. That's going to be called, I'll call it C here in our Pythagorean theorem. So if we do a squared plus b squared is c squared, 10 squared plus 13 squared is c squared. 10 squared is 100, 13 squared is 169. So that's 269. Oops, that's not how you write a 9. And all we need to do is take the root of both sides, and the root of 269 is 16.4. So we choose 16.4. Looking at this, there's only, again, one good choice. A is shorter than either of our two short sides. Can't be. This has got to be the longest side. And C and D are ridiculously long. If this is 13 and that's 10, 269 or 130 between them? No way. That's way, way, way too big. It wouldn't ever fit. You can always test this with a ruler and a piece of paper. Try to draw that triangle. If you can draw it, it can exist. And if you can't draw it, it can't exist. Next, the legs of a right triangle measure 11 and 8 centimeters. So we've got a right triangle, and they are going to be 11 and 8 centimeters. And we want to know the length of the hypotenuse. So we do what we always do in this right triangle situation. We use this thing made up by a guy a long, long time ago, thousands of years ago. Notice this bit about right triangles. So we take 8 squared plus 11 squared equals c squared. 8 squared is 64. 11 squared is 121. (64) and 121 is 185. And if we take the root of 185, we get 13.6. And we look over here, and none of these say 13.6. Ah, but one of them does. One of them says root 185. That's 13.6. Good enough. So not written in the most obvious way, but there it is. I think we've only got 3 left here. I think I can actually get through these all. Let's find out. Next, which of the following angles is equal to angle 4? So angle 4 is right there. And we know the pattern. The opposite ones are equal, and on the other set of parallel lines, those same other ones are equal. So we're looking for 4, 7, 2, or 5. Nope, nope, yes. The other angles here, 1, 6, 3, and 8 are all equal to each other, and like 3 and 4 would add up to 180, or 4 and 8 would add up to 180, or all around the circle would add up to 360, but here they're just asking for equal to angle 4, so we're looking for this pair or that pair, any of those. Next, angles M and N are complementary. Complementary means that they add up to, so the symbol here is the sum, sigma, it's just a Greek letter S, and they sum to 90. Complementary angles are 90. So if angle M is 34, what's angle N? We just need to do 90 minus 34. And 90 minus 34 is going to be 56. So we would write in 56 degrees. Next, lines P and M, so this line and this line are parallel. So we have a transection going on here. And angle 2 and angle 4 are opposite angles, although they didn't have to tell us that, we can see. What's the measure of angle 4 in degrees? So we're looking for this angle in here. Well, how big is this piece? There are a few ways to solve it, but the simplest one is to say that from there to there needs to be 180 degrees. If we're going along the one side of a straight line, that's 180. The other side, that's 180 as well. All the way around the circle is 360. So if we take 75 plus angle 4, we don't know it, plus the other 75 to get to 180, all we do is we take 180 minus 75 minus the other 75, and that's our unknown angle. So our unknown angle is 180 minus 75 minus 75. It's going to be 30 degrees. 75 plus 30 plus 75 is 180. Which means that this angle here is 75, this angle here is 75, and this angle here is also 30. If we wanted to know this angle, that's the same as this angle. Just we're going to keep going on. The answer is 30. This one is also 75. This angle and this angle are the same. This angle and this angle are the same. That's also 75. So this triangle here should add up to 180. 75 plus 75 plus 30. Yeah, that angle adds up to 180. And this angle on the other side, it doesn't ask us for it, but here it is. That one, same as that one. We know that from here to here should be 180. So 180 minus 75, this is 105. We don't need to find it, but there it is. Took us just a few seconds. Okay, last one finally, and we're done with this assignment.